Right. Next up is Ivo.
Thank you. So I thank you for a very nice presentation about Bazel mod. I love where the whole idea went and how the module.bazel syntax looks like. It's really amazing and wonderful work from both of you, Yun, Shudong, and others in the community. My talk is about Bazel rules. Okay. So Bazel rules are probably one of the most extendable parts of Bazel, and actually even a very large part of our code base. They allow you to support arbitrary languages and also other things beyond languages. I will roughly split the presentation into 3 parts. Past, present, and future, or maybe almost past, as it always is. Stereotypification is the first part. Then our present is implementing the new APIs to extend and structure the rules. And last but not least, I would also like to present some of our future plans and ideas that we are discussing. So this is one of the slides from previous keynotes. The stereotypification project is about rewriting native rules that are part of Bazel that were written in Java into Starlark. And then at the end, we would also like to split those rules away from Bazel. Does anybody have any idea how many lines of code we are talking when we are talking about native rules in Java? So its implementation, it's around 250,000 lines of code. Together with tests, it's 380,000 lines of code. Now, next question. How large do you think the sub-team at Google is that is doing the rewrite? Actually, there's 1 person per language, roughly. At best times, we had 2 persons per one language. But that was an exception. So this is the progress that we are making, counting actually all the lines, not just the lines of code. On the left side, you see lines of Starlark code that we've written over the years. The order of magnitude here is 10,000 lines of code. On the right side, you can see the amount of native lines of Java code. The order of magnitude here is 100,000 lines of code. Where are we? So how are we doing the rewrite? We are moving from outer layers into inner layers. The most outside layer being the rule definition and some implementation that directly pertains to a single rule. Then we are moving into middle layer, which is a shared rule implementation. You will see common providers like Java Info here, Java Common Module, or CC Common. And then the last thing in our plan is to rewrite the actions that are special to languages. We already did the rewrite of languages that actions that can be rewritten in Starlark already. So starting with proto rules, the rewrite is complete. The number of lines of code here is not exactly correct because there's only proto library and proto common. Also language proto libraries that were part of core are done. And the rewrite here is complete. So all the layers, outer, middle, and inner layer. Python rules, we had support from external person, another team member at Google. The rewrite is almost complete. All of the layers are covered. There is some use of private API, which would involve either cleanups or extending the API that Bazel provides. But the state is pretty good here. Similarly, it is with Java. Java rules are written up to the middle layer. There is a special Java compile action, which we are leaving for later. What you, for example, can see on the right side, there's still a lot of code in there. So the biggest chunks there are C++ rules, Java, and Android rules. Why we can't remove Java? Well, because we need to rewrite more of Android rules first. Android rules, they are handled by Alex, so he can probably answer your questions better, but the rewrite is you won't see it here on the built-in starter rules because the project took a different approach and wrote the rules directly in the repositories, in the depot. But also the large majority is done. I believe that Android binary is the most essential missing part there. During our rewrites to Starlark, so for example, Java info is nowadays and proto info in Starlark, we also needed to improve Starlark providers. So we did several improvements. Those improvements also were okay for others that are already using Starlark providers, mostly about reducing memory footprint. The result is actually amazing. In one case, we actually have better memory consumption in Starlark than in native. What I'm leaving for the last here are C++ rules. You can actually see a large code of a large chunk of Starlark code already written. Also a large chunk of code in native still there. Those are probably the hardest rules to rewrite. We moved this year into rewriting the middle layer, but we haven't finished yet, and we'll probably spill this effort into next year. Also, one thing that you are not seeing on all these slides are we are also handling other internal-only rules. So now, if you, how good idea do you have about how big is the whole Bazel team? So looking at the front row, probably most of the team could sit there, maybe a bit in the second row also. So if you imagine that Bazel team is its own company, it's a very, very tiny company. Google is a very large client, and we don't really have good means to know about every language and to do support on every of the rule sets. You can even imagine how hard it is to answer all of the GitHub issues if there is one person per language that we currently have. We have an agreement that the best maintainer or owner for the rules are also the toolchain owners, because toolchain owners usually have also the expertise in the language. So this is internal restructuring, or I'm not sure if I'm able to call it this way, that we are trying to achieve. Externally, we are also going to move the rules eventually into separate repositories, and this was actually the ask from the first day. We will need to ask the community to do the maintenance because I think our efforts in our teams are better used in improving the core functionality. We are the experts there. What we will continue to do is offer support and advice how to implement new features, either at Google or potentially also externally. So once those rules are moved into separate repos, there are going to be more people involved, and there is potentially some need for governance of those repositories. We we prepared some procedural proposals about this and also some proposals about how to best maintain rules repositories. I believe that community also has such ideas already, and I don't think that they are incompatible in any way. It's just another set of ideas how to structure the rules repositories better so that they are also easier to maintain. So one big problem that I'm talking about is maintenance of the rule sets. And there is also an idea that once those rules are in the repositories, you're able to fork them and implement your own features or remove the features that you don't need. I would say that this is a bad idea. We have an example internally. We have a couple of forks of Python rules. The maintenance, well, you would think that for Python rules, you need 3 persons to maintain them. At the moment, we have 1. Think about that before forking the rules, because when the maintenance is dropped, this becomes the user's problems, and they need to either maintain the rule sets or migrate to another rule set, which is never fun. To alleviate this problem, we are working on a proposal how to extend the rules. So basically, the idea is do not fork, but extend them. So what we imagine will be part of Bazel or part of the rules repositories that are maintained by Google are baseline rules. Those are actually the rules that you nowadays see in Bazel, the major ones, the Java, C++, Proto, and Python. And from those baseline rules, if you need additional features, we don't have time to implement or maintain them, you can extend the baseline rules to implement those. So it's possible to either do the extension internally for arbitrary company or to do extension for smaller Bazel users. To be true to this cause, we are also going to do the same internally. So all of our Google rules will be extensions of the baseline rules. This way we can meet different needs. And one thing also more important, once Google language expert take over the maintenance of the rules, if they have to solve a bug, fix a bug, they will most likely need to fix it in the baseline rules if it happens there. So you also get the same, you reduce the maintenance cost, and also Bazel community gets the fixes. If internal team needs to implement a new feature, we'll consider if it's generally useful and either implement it in internal rules or in the baseline rules. So here I have an example how the extending rule works. Maybe one thing, what's the first thing that you notice about this code? Well, it doesn't compile. It's written upside down. You have the definition. So here is an example of Google Java library. Its parent rule is Java library. It has its own implementation function. And then the attributes are actually merged from public attributes from Java library. And you are able to override an attribute to, for example, here add an aspect to it. So the public contract is somewhat compatible to Java library rule. This somehow affects also the projects that Google open source. If we would like to move from Google, a project from Google tree into Bazel, we would like to keep the same interface for the rules, even if there are some features missing in the baseline rules. The rule has its own implementation function, and it can call it actually has to call exactly once the parent rule. So that's context super. It returns the providers. Then the rule is able to add some providers to it and return them. That's the very simple basic ideas. We are also adding some cookies on top of that. And we are pressure testing this idea against our internal rules. So most likely we will add additional API where we need them, but they will also be useful for others. Second API that we are working at present on is subrule. This one is more about structuring the rule. The origin of this idea is coming from previously proposed coding guidelines. There was a ton of user response on those coding guidelines that it's hard to just follow the guidelines, that we actually need an API that enforces these guidelines. So structuring the rules proposal implements a new construct that's called subrule. Subrule is intended to be reusable and also to be well encapsulated. So here you can see an example structure of a binary rule. It would need to compile and validate the sources, for example. It would reuse basic libraries. So those smaller circles are example of subrules. And then you could also have a linking subrule. Those parts could be also reusable, some of them in implementation of a library rule. How does the code look like? Also written upside down. So you have an Android lint call, which is a subrule. It has its own implementation function, and you are able to define implicit dependencies or private attributes. Those are the encapsulated parts. Only the subrule can access those private dependencies, and it can expect to work in different contexts. The implementation function is a bit special. It takes context as a parameter, but this context is very small. It doesn't have any attributes. Then source file is an example of an arbitrary parameter. Types are not fixed there. And the last parameter is the Android lint tool, which gets injected into the implementation function. So you access it over the parameter. What the implementation function can do, it can declare new actions. It can do anything. It can also call other subrules. It's able to work with providers, construct them. However, you see best splitting and structuring your code. How is such subrule used in a rule? So you import the Android lint call. You need to declare it on rule where it's being used. And then from the implementation function, you only pass in that 3 parameter source files, and the context and the implicit dependencies get passed in automatically. Where are we with this? So this is a partial roadmap just talking about the new API. At the moment, we are wrapping up experimental implementation. We would like to cherry pick that into Bazel 7. It's not completely finished yet. And we would also like to ask everybody, users, to test drive the implementation and report where the problems are. Along with that, we are also refactoring baseline Java, C++, Python rules so that they fit this model, that the rules can actually be extended. In Q4, we will mostly focus also on using this API on the internal rules. We are going to structure the Java rules using a subrule. Java rules are a good playground in this respect because they are complicated enough, but not too much. And the last goal is to also consolidate this API. Later on, we will reassess if this API should really be generally available. So at the moment, it's going to be available only under an experimental flag. Now, the last part, future plans. So Bazel has a motto that it's fast and correct and you can choose to. What nobody is telling you that you will also need some more RAM. So fast, correct, no memory consumption, choose to. But we do dream big. So here is a quote from Bazel team member. I'm not sure I heard 95% correctly, so I will keep this source anonymous for now. So I already mentioned consolidating the API. Our future vision is standard built library. What we would like to achieve is, after all the rules are in the depot, that we have also a standard library with which the rules are created. We would like to have this library as small as possible, as stable as possible. Why? Imagine if this interface is stable to Bazel, then rules repositories can have a completely separate timelines from Bazel releases. So you are able to get features faster or bug fixes. Next one is include scanning. This is another long-term plan. Once we are finished with middle layer of C++ rules, we would like to look into how to support this in a better way in C++ rules and potentially also expose the API for other rules. And I must say that I'm conflating include scanning with a lot of things that are happening in C++ rules. A bit of imposter here. So back to reducing memory consumption, and those are my last two slides. First-class macros are a current effort, which is looking also into reducing peak memory usage. Quick run through. So those are also called symbolic macros. The design is already online. We are bringing macros closer together with the rule, and we are enforcing the coding guidelines on the macro. So macro needs to have a name and needs to create targets that are following the prefixes. Last but not least, introducing type annotations and decorators for Starlark. This is far, far away in the future, I guess. But also notice one thing on this slide, it's the first one that's not upside down. Thank you.
I bet there's lots of questions.
I have a question regarding rules extension. So is the functionality only limited to adding additional providers, or can you also invoke like additional actions?
You can add actions. So we have a big discussions if you should return all of the providers in the same shape from parent rule, or is there another way to meet is a relationship? So we have some use cases internally where we slightly modify Java info provider, and this seems to still meet is a relationship. So we'll probably allow some modifications to providers as well.
Will it be also possible to, for instance, extend the list of outputs? Because it can be especially handy if you have like static code analysis, because usually those like you need to intercept the compiler call, and then you need to add an additional input output, which is basically some data file.
This is modifying the fault info provider.
Yeah.
Yeah, you can.
Okay. Super. Thank you.
Good question. Let's go over all the way over there on the left. My left.
You mentioned that the best owner of the rule sets are the toolchain owner. Did you convince Android team and Go team to own rules Android and rules Go?
I asked before SLS about that.
Sorry, the extending the rules, does that require the rules to be implemented in Starlark? Like if we wanted to implement, like enhance the CC library rule, for example, does that require the work to be done for the Starlarkification? Or
so outer layer of CC library, CC binary is already done. It's a built-in rule in Starlark, and you are also able to extend built-in rules.
Okay, cool, sweet, thank you.
About the new macros, how does this affect the querying capabilities? So am I going to be able to query macro targets? Am I going to be able to dig into the underlying rule targets? What sort of is the vision there?
We don't know yet, but we know that we need to support query there as well.
A quick question about the creation of or modification of dependencies of actions after they're run in the way that CC compilations do, where they're parsing MDMFs or the equivalent of any language. Does that mean that that's going to be accessible via Starlark? And will that be generally accessible? Meaning I could write it for whatever language I choose, where I can change what files influence invalidation? I know this is a long question.
We would like to do general support. Actually, on these projects, we don't even have design candidates yet.
Ideas welcome, though. Somebody has a microphone.
I have a microphone, yeah. So I have a question about the type annotations that you mentioned, because I think I heard from the back2 people that they already have static typing in Starlark. So I wonder if it's going to be compatible, or you're talking to them.
Yeah, so actually we are starting from a different perspective. I was thinking about those types because I would like to reduce boilerplate that's around rule definition, and I would also like to bring macros and rules closer together. So a typical constraint is that it's very easy to write macros and very hard to write rules. Having more similar syntax, I would also like to see that users get more comfortable writing the rules. About the question, yeah, I think so. The back2 approach is a bit different. They're typing just Starlark functions, not rules, macros, or other things. But it makes a lot of sense to work on compatible type structure, and we have a lot of fear here. Types are hard. Even major languages made mistakes there.
Hi there. If you wouldn't mind just flipping back to the nice graph you had about the progress of the Starlarkification. It's really great that it's going down all the lines of Java code, but if you look really in there, it looks like the lines of code in Java. Have any comments on that?
Yeah, we are using private API. So sometimes we expose new API to the built-in Starlark rules because we know we need to follow up with a cleanup. And it's probably better that we schedule them separately, not together with Starlarkification.
So yesterday, Tobias got asked about C++ 20 module support, but he deferred the question to you. So here we are, and in particular, in relation to the lack of dynamic dependencies, how do you think this can be implemented performantly? And what can the community do to speed this up?
I need to explain my imposter syndrome here. One person per rule set, I'm doing Protos, and I never written a .proto file in my life. C++, it's a bit the same. Our main focus next quarter are going to be C++ toolchains because they proven to be the biggest pain point for the users. We don't have module maps on the roadmap for now. Those might happen later when we learn more about them.
I think someone has a mic there. Yeah. Please.
Just one question about symbolic macros. One question about symbolic macros. Will there be a way to control like visibility of targets that are created in those macros? Like, can I have, let's say, private intermediate targets, or will everything be exposed in the build file?
Oh, that's an interesting question. I don't think the visibility is part of the proposal at the moment, but I also think that we should consider it. In general, what's within the macro, only the main target should be visible and not the auxiliary targets.
Because
in principle.
Because it says like make tests and everything, which kind of has or seems to be able to be accessed from outside. I don't know, but just by test runner or anything.
Tests can be private. You can run them directly.
Okay. All right. Thanks.
One last question. Evo will be around the rest of the day. And probably
There was a quick mention of module maps. I just want to say that's not C++ modules. That's something different.
Where can I hide? Maybe I also need to mention there's rules, birds of a feather coming after, so there's also time for more questions.
Exactly. So thanks very much, Evo. And again, keep the questions coming.